Hello, my name is Rob Garner. I am a computer programming instructor, and today I'm going to demonstrate how to build a basic class in C#. So I've already created a solution. It's called the Student Class Demo, and it's a console application, which means that it defaults by giving us a program class. And what we're going to do is we're going to add another class. So we're going to right-click on the project, Add, New Item, and under C# we're going to pick a class and we're going to call it student. Now we could write our class manually, just writing the code in here, but Visual Studio gives us a way of doing it a little bit more automatedly. So we're going to demonstrate that first. If we go to our student class, right click on it and click on View Class Diagram. What we get is this visual designer that we can use to create our class. So we're going to start off, and under fields we're going to add some common fields that you would expect in for a application recording information about a student. So we can say major, and we're going to make that a string. We're going to add score 1 and make that an int. Score 2, int. Score 3. Student first name, and that should be a string. Student last name, again a string. And student number, which although it says student number, we're also going to make it a string. Notice that we make all of these private, and normally field names do tend to be private. We'll talk later about how we will use methods to make them available. Once we've put all these fields into this class diagram, we can look back at the student class, and you'll see that this code has actually been written for us. So it's a convenient way of writing code, but you could have just written the code directly yourself. It's up to you which way you find more convenient. So in effect, we actually do have a class now, and we could theoretically use it. I'm going to go to Program, and we have a new class called Student. And we're going to use this syntax to instantiate a student. And basically the way this syntax works is, in our main method in the program class, we're going to instantiate a student of the student class we just created, and we say we declare a variable called myStudent, which is a student, and we're going to initialize it by setting it equal to a new student, and this thing here, this method here, is called a constructor. All classes start off with a default parameterless constructor, and so even though we haven't declared a constructor yet inside of our student class, we just have some field names, we can actually instantiate one right now. To kind of show what that default constructor looks like, we can just write one, and we're going to put it into our code. And it's basically written just like a method, except that, for one thing, the name of a constructor must be the same as the class. You'll notice that there's no return type, and since there's no return type, that's how Visual Studio knows it's a constructor. And we're not going to put any code in here, but often what you might do if you were to actually override the default constructor like this is you would put some code in here to initialize these values. Now going back to our program, now that we've got the student, what can we do with it? Well, if I put my student and hit a dot, you'll notice that not much comes up. And the reason is because right now I've declared everything as private. If instead of private these were then made public, and then I went back to my main program, we'd see that suddenly all of these fields would now be available to us. Now on the surface, this seems like a good way of giving access to these variables, but unfortunately it doesn't give us a whole lot of control over what happens with these variables if we make everything public. Instead, we're going to leave these things private. And so generally speaking, we make our fields private. We make our constructors public because, well, you wouldn't be able to use them if they weren't public. And in order to access our variables, we'll actually use methods to do that, and we'll create methods called accessors. So in this case we're going to create an accessor called getMajor. It's going to be public, it'll return a string, and it'll return the field major. After saving this, I'm going to go back to program, and what we'll see is that that accessor is now available, and it says getMajor. And generally speaking, when we write an accessor, we use this format: get, and then the field name, and it's all capitalized, or it's the first letter is all capitalized. So getMajor is considered an accessor. So now that we have this getMajor function, let's try to set something into it. And what we notice is that if we try to set something into the getMajor method, we get an error. You can't assign something into an accessor method. And while this looks like it's unfortunate right now, it actually is one of the things that allows us to control very much what happens with a field. If we just provide a field, you would always be able to both read and write into that field. By creating an accessor, I can make it so that you can read the field, but you can't write into it. So sometimes I want the ability to only be able to read from a field, and this would give me that capability. The other approach, the other thing though, is that sometimes we want to both be able to read and write into that method or into that field. And so if we're going to use a method to do it, what we create is Mutator functions. Mutator functions are always void. They usually are called set and then whatever the field name is, and they take a parameter, which is, I want to call it new major. That's what we want the major to become for this student, and what it does is it sets major equal to new major. And so rather than trying to set into get major, what we do is we set major, and it's a function. It takes one parameter, which is what we want the new value to be. And so this is how we're going to set values into this mutator. So if I want to access what major is now, I just say my student dot get major. So that's where we would normally use the accessor function. So we use the mutator function, the set function or method, to set the major, and then we use the accessor method or the get method to get access to it. And if I run this, it should work. So we can see that this actually sets computer programming into the major and gets it from this student, my student, which is the student class, which is defined here, which has a mutator and a accessor and one constructor. So one of the powerful things about classes is we can define all this functionality in the class, but we should be able to use it multiple times. And so let's try that out. So we created one student, which is a computer programmer. Let's instantiate another student. So we can see that we're instantiating it about the same way, and we'll print out the other majors, the other student's major, just to prove that we actually have this working. So my other student is the identifier for this new student. My student is the first identifier for the first student that we instantiated. But notice that both of them, I can put the dot operator and get major. And I didn't have to rewrite that code because I'm using the same object or the same class declaration. So I can instantiate two objects off of the same student class. And this allows me to repeat using that functionality. And if we run it, we see this in fact worked. Computer programming was placed into the first student's major, and we didn't initialize the other student's major, so we need to do that. So again, we'll use the set major function. And that set major function for my other student is the same set major function for my student, which is defined in the class. And we can see it does in fact set different values for each of those students. So the important thing to take away from this is that even though they're both pointing to dot get major, they're going to get two different results because my student.getMajor is going to get the major of my student. My other student.getMajor is going to get the major of my other student. And so the fields are different for depending on which object is being called, but the methods execute the same way. So one of the things to look at is notice that our program class, the main method, is declared as static, but in our student class we didn't use the word static in any of our methods. And why is that? Well, this accessor and this mutator are both instance methods. That means they're associated with the objects that are declared. In this case, my student and my other student. If these are declared as static, notice that we get an error. Major is not a static field, so we'd have to declare that static as well. And if we did that, we'll notice that in programs, suddenly set major for both my student and get major have a fault. And if we look at the fault, it says cannot be accessed with the member student class demo.getMajor cannot be accessed with an instance reference. Qualify it with a type name instead. And so what it's really looking for would be student.getMajor. And what that will do is we won't be able to set a different major for each student if we did that. There's only the variable major, and if we have the static keywords here, only represents data for the overall class, not each individual student. So that obviously would not make a lot of sense. If we did that, for example, and we fixed it this way, and we ran it, what you would find is that both of them would be set to art history because they're only pointing to, so even though I set the first student's major to computer programming, they're both set to art history after the second call to set major, because it's setting a variable which is associated with the class, not with each object. So that obviously would not give us the functionality we want. So we're going to undo all that. And now our functionality works the way we want it to. So that concludes our initial demo on building a basic class. We built some fields, we created some accessors and mutators, and we created a constructor for student. Now the remaining exercise would be we only created accessors and mutators for major. We would want to do the same accessors and mutators for scores and for student first name, last name, and student number. That completes my demonstration. Thank you very much.